So now that we've got our chain features created and named, we're going to go ahead and create our first cutting operation. And we're going to create a pocketing operation in our pocket. The first thing you'll do there is select the pocket chain. And you could select it down here, or you could select it in the features toolbar. You can go over here, turn on the solid mill traditional toolbar, select the pocketing operation, and that will open up here a pocketing tab inside our project manager. Now, our pocketing operation has a general tab, a strategy tab, a pocketing tab, a rough tab, a links tab. If I come over here and I set this wall finish to yes, it will open up a wall finish tab. And if I set floor finish to yes, it will open up a floor finish tab. So for this operation, we actually are just going to do the roughing passes. We're not going to do a wall finish or a floor finish. The first thing that we need to do is we need to tell Esprit which tool we're going to use to do this pocketing operation. Now, the tool has to be small enough so that it fits inside the pocket. It actually has to have a small enough diameter so that half the diameter is no bigger than this smallest radius in here. We'll go to our tool list here. When we created this file for you, we put some tools in it for you. We're going to use the 3/8 inch end mill. So go ahead and select that 3/8 inch end mill. For the most part, we'll stick with the default parameters here that Esprit has given us. We'll go to our strategies tab. Now, I like to use the concentric out strategy here, so we're going to start in the center of the pocket and move outwards. We'll select concentric out. It doesn't matter if you select the morph move or not. Now, I like to use the spiral move. I'll say yes there, and that's just a little bit gentler on the tool. It will constantly increment the amount that it's moving out as it goes around. We can ignore this smooth rough corners. At any time in any of these operations, if you want to, you should go to the context sensitive help. Go ahead and open that up. It will bring you right to the page for the type of operation that you're on if you're in one of the operations. You can come down and you can learn about. Let's see, we're in the strategy tab now, so we can go to our strategy tab. We can come down here and we can read about what all these different things in the strategy tab do and how changing them will affect your part. So take a moment there to go through and read those if you'd like to at this moment. For now, I'm going to close the help. We're going to ignore these. Now, our total depth, and because we defined the depth when we created that pocket chain, it read that right off of there. If we had just defined the top edge of the chain, we could go in and type in our total depth. It's got the incremental depth set to 0.375, and it did that because it's guessing that our tool will allow us to go a full diameter in depth there. Now, you can overwrite that and change it to whatever value you want. The starting depth is 0. Now, that starting depth is measured from the XYZ 0 that's defined as the work coordinate. So you can see that's up in this corner of the workpiece here. So you see this is our UVW axis here, or XYZ axis, where Z is up direction, this Y in this green direction, X is the red direction there. And you can see that it's coincident with the plane that defines this top surface here. And so our starting depth will be 0 because we want to start cutting the pocket at the 0 point there. So starting depth of 0. We don't really care about this surface clearance and retraction thing. Now we can scroll down here. There's some other options about priorities. Do we want to use stock automation? We're going to select no. When you do select yes, and later in the class we will be selecting yes for stock automation for some operations, it will take longer to calculate that toolpath. So for now we'll say no. In the pocket tab here, our pocket doesn't have any islands in it, so we don't need to identify any islands. There is no taper, but it's fine if it reads it from the part. In the rough tab, and so this is telling us the toolpath motion that it would do for the roughing operation, and again, we're not going to do any finishing operations, so this is the whole shebang, as they say. Our cut speed, now you can look this up in your spreadsheet that you created in the previous lesson, or you can go back to the source material that you used for the spreadsheet. I don't have my spreadsheet handy right now, so I'm going to go back to the mill tooling page on the MFE Labs website. And I remember here that our Haas mini mills have a maximum spindle speed of 6,000 RPMs. And so regardless of how fast the tool wants to go for surface speed, the maximum that we could do is 6,000. So I'm going to go ahead and put in my 6,000 there. 6,000. And it's going to automatically calculate in the next box over what the surface feet per minute is, or the SPM, Esprit calls it. But that's our surface speed, and that's in feet per minute. So 6,000 is about 590 feet per minute with our 3/8 inch end mill. Now, it can't do that calculation if we haven't already told it what the tool diameter is. Back to our rough tab. Okay. And so our XY feed rate, and if I scroll down here, and so let's assume that we're using one of these 3/8 end mills that we've got here. And I'll scroll down here. Our material group is non-ferrous. It's N1 for aluminum. And we're going to come over here. And so at the 3/8 inch end mill, it wants to do an XY feed rate of 0.0034 inches. And so I'll go to these. That's the per minute box. I'll go to the per tooth box, 0.0034. It automatically counts the per minute feed rate based on the spindle speed that we put in. And for our Z-axis feed rate, and again, remember that we never want to plunge directly with one of these non-center cutting end mills into the part. We do still have to tell it how fast to feed when you're moving in the Z direction. And so what we do is our rule of thumb here is we use 1/10 of the feed rate that was there, which is pretty easy for me. I can do 0.00034. Put that in there, and it calculates it. Now, I hit return, and it automatically exited out of it, and it created a toolpath. I can now double-click on that toolpath and open it back up for editing again, because I hit return and I wasn't quite ready to. So let's finish going through here. So we're going to use a climb cutting strategy. It suggests that it automatically selected a 50% step over, but for our tool, the tool manufacturer says for step over here, it says that we can do a whole diameter in our AP value. Now, or AE value, sorry. AE value is this one here. So it says 0.5 inch diameter. With our mini mills, we're sort of power limited, and we're going to cut that back to 0.25, or sorry, if you do 0.25, it thinks you want 0.25%. We'll do 25% step over for this tool. And then we'll leave stock allowance walls. So we don't want to leave any stock allowance on the walls, no stock allowance on the floor. In our entry mode here, there's a few different things you can select. Now, we never want to plunge into the part with this end mill. It's our last resort to plunge in. We can do ramp along pass, plunge at point. Now, again, we don't want to plunge whether it's at a point or not. We can do a helical at a point. We can do ramp contained, which means it just ramps inside the part, but not necessarily along one of the passes, and a helical contained. And so for this exercise, let's go ahead and select helical contained. We have a minimum radius, so that's the smallest radius we'll let the tool do. We'll set our helical angle, and so 10 degrees works for a lot of tools, but with these smaller diameter tools, let's go with a 5-degree helix angle. This edge clearance means how far away from the edge of the feature do you want it to stay while it does this. And so we'll use 50 thousandths there. And if entry fails, skip. The other option here is if entry fails, plunge, but we don't want it to ever plunge in the part. So we're going to select if entry fails, skip. Exit mode is ramp, that's fine. Exit mode is ramp, that's fine. Scroll through this. And so this is how it's going to enter the part when it begins cutting. This is how it's going to leave the part when it finishes cutting. On the links tab, this tells you how high up does it move and where does it move to when it's going between two cutting operations with the same tool. And so our clearance here is 0.1. We're going to return to this clearance plane. We're going to retract to the clearance plane, and that's if it has to move up in the middle of the operation, which it doesn't have to do here. Now, this 0.1 could come to bite us because this boss is 0.125 inches tall. So what we're going to do here is we can change this 0.1 to 0.3. And then whenever it retracts, no matter where it moves from here, if it moves sideways, it won't run into that boss feature. So I'm going to go ahead and click OK. And again, if you clicked OK before you needed to, you can always double click on the operation to make it work. The next thing we want to do is we want to go ahead and simulate this operation and see if it looks like what we expected.